An efficient fielder can stop a cricket ball with his hands and prevent the batsman from scoring a boundary. Can anyone stop a fast car that way? When a man runs into a parked car, he won't be much affected. But if the car is moving, even at a moderate speed, he is likely to be seriously injured. The force of a moving car in collision with the man is likely to be severe.
When the man runs into the parked car, the impact is smaller, because the man's mass is smaller than that of the car.
We need less force to stop a moving ball, because its size is smaller. We require more force to stop a moving car because its size is greater. Let's compare a flying cricket ball and a bullet fired from a gun. Can we expect the same impact in both these cases? No. Though the bullet is smaller than the cricket ball, its speed will kill a person when it is fired from the gun. But the cricket ball does not hurt so much. What do you infer?
The mass alone does not give us an idea of the magnitude of force required.
Speed is also necessary to explain the force.
Momentum is a physical quantity. It is defined as the mass in motion. It is useful in calculating the force.
It is useful to find out how much stuff is moving and how fast it moves.
The momentum of an object is defined as the product of its mass and its velocity.
Physical quantities are of two types. They are scalar and vector. In carom, a game in which a striker is used to hit and move other coins, a carom board coin moves 10 centimeters when it is knocked by the striker coin. Scalar quantity depends on magnitude only and does not depend on direction. A striker coin moves 10 centimeters northwards and bounces 10 centimeters southwards. The net displacement is 0, though the total distance covered is 20 centimeters. Vector quantity depends on both magnitude and direction. Example, displacement. Velocity is the rate of displacement of an object. Therefore, velocity has magnitude and direction. It is a vector quantity. Similarly, momentum is also a vector quantity. It has magnitude and direction. It has the same direction as that of velocity. Its SI unit can be derived as shown here. The SI unit of momentum is kilogram meter per second.
Let's consider a truck and a bicycle moving down the street at the same speed.
Which will have greater momentum? The truck will have greater momentum because of its size.
Let's consider the same example, but now the truck is at rest and the bicycle is moving. Which will have greater momentum? Now the bicycle has greater momentum, because when there is no motion, the momentum is 0. Hence, the truck has 0 momentum.
The momentum of a ball is 8 kilogram meter per second. Have we expressed the momentum correctly? No. Momentum is a vector quantity. It has the same direction as the velocity of the ball. Therefore, we should mention direction as well. Bird strikes on aeroplanes usually occur at lower altitudes during takeoff or landing. Though the size of the bird is less than that of the aircraft, it can cause a lot of damage to it because of the greater velocity of the aeroplane. Many airports have bird management initiatives to chase birds away from the airport. Most of the aircrafts are subjected to bird strike tests as well for protection. Sandblasting equipment is another application of momentum. Applying sand at low pressure on a rusted metal component will not affect it. But when the sand is applied to the rusted metal component at high pressure, it removes the rust and heavy scales and makes the clean, bare metal visible. This is known as sandblasting. Car bumpers are made up of lightweight, high-impact resistant plastics to reduce the collision impact in the event of an accident. This prevents a direct hit on the metal components.